This is my new little project called Tessera Twist, which slices an image into multiple vertical or horizontal pieces, shuffles them, and creates a time lapse from it. So this is how you write this project. First, create a GitHub repository, but since you are a noob, you ask ChatGPT to name it for you. Also, don't forget to say thanks. Next, find your first clue by asking a dumb prompt and get a dumber answer, which is still enough to get you started. Add useless shit to your newly installed IDE. We are using Python Bros, so we use the package suggested by GPT called Pillow, which can crop an image for us into pieces that we want. First, I copy the GPT-generated code, then change it to crop image horizontally. You'll see the code a bit slower very soon, but remember the video is not about all the details of the code. You can find the source in my GitHub repository. Then I download a photo from Unsplash to test the class. The output is messed up, so I go back to my code, read more docs, and understand how coordination system works in Pillow library. My class accepts number of pieces and loops over it to create horizontal slices, which right now it was vertical. Then adds those crops into a list, and using random package, it shuffles the list and generates a new image. After some research and bug fixing, I finally managed to create a desirable output. Implementing vertical slicing should now be easy. I use the same coordination tactics to slice the image vertically. After so many failing attempts, I finally got it right. The results worked in both sample images. What I realized was that everything in both horizontal and vertical implementations were identical. I just needed an abstract method to return coordination per piece index. So I made that change. The next step is to generate multiple random images. To do that, I created a new class called Sequence Generator, which 1 gets input image and output directory, 2 accepts number of random images to be generated, which equals to the FPS or frame rate, 3 accepts a factory function that returns either vertical or horizontal image generator object, and finally, generates images using multiple worker processes. Fortunately, Python multiprocessing package made everything easy for me, and in a few minutes the class was ready. Also, to test how it looks and finally make it optional, I tried to shift the slices instead of shuffling them every few images. This can result in a smoother looking final video in some cases. At this point, the only thing that was left was to create the time-lapse from all the images. I have done this before using FFmpeg library, so I did a little search to find the arguments that I should pass, and changed some of them so it applies to the folder full images that I already have. I was absolutely satisfied with the results. So going back to Python, I create a new class called timelapse generator, which accepts the location of FFmpeg binary and few more parameters to change the result, such as FPS and dimensions. Then I create a new video using that class. This is the final touch. We are going to use Python's arg-parse library to accept command line arguments. Everything will be parameterized, such as input image, the type of the randomizer, number of pieces, frame rate, duration, location of FFmpeg binary, and more.